your meet tonight at 5 o'clock. The PreCalc meeting is scheduled today over lunch. You have not heard one way or the other. I'm assuming it's still on if you're interested in speak about it. All students are welcome to attend. Student-led volunteer organization, 5 members up to serve, build character, and leadership.
Hope you got your notes out. We're going to hit the ground running.
Senior, eligible 355 and higher for the National Honor Society. You have until tomorrow. You'll be here at 3:15 to get your application. You were scheduled to take the PSAT test yesterday. That has been rescheduled for Tuesday, October 26th, box 1 and 2. Teachers, please note that as well. Those students that you received that would have taken the test yesterday, now Tuesday, October 25th. Your senior class officers, student council, and you meet all of you on Monday, October 18th, 1:45 in the library conference room. You have graduation items you're preparing for and to set. Also, seniors, please note that next Wednesday, 20th, during the advisory day, your part of that may be to meet with the job rep to go over the rest of the graduation and order the items that you need dealing with graduation. Seniors will report to the auditorium next Wednesday, the 20th. Senior class officers that you meet with on Monday during class. Orange County Coalition, the Pride survey also on the 20th for all students that their parent returns the permission slip. If you're interested in that, your parent has not returned it, there will be a drawing for a couple $100 gift cards, and you will receive a full-size candy bar for your participation. Talk to your parents about the form that's been emailed to them a couple times, and return that by the end of the day, Friday, if you're interested in that survey taking next Wednesday. So please stand for the pledge. To the flag
of the United States of America, and for the republic for which it stands, one nation, under God,
All right. You're the only class that gets cut short today because of the maroon schedule. You all know you're in here. After this, you go to lunch. After that, it's 2 and 3 normal blocks, no Spartan time. Okay? So everyone knows what you're doing. This one, we still have lunch at 11:24, so we have 66 minutes. Nope, 5. Okay? So no daily quiz. I'm assuming that if you didn't ask questions in the last 48 hours that you don't have any. Or you're just being that kid. So we're just going to jump straight into 4. Right? Everyone's good? Got our notes? Game on? Okay. Normally, we would have done just the usual being that stuff, but oh well. We did upper and lower boundary tests. It was one of those things that's pretty useless if you have a graphing calculator. If I got a graphing calculator, odds are I can just look at the graph and I can say all the zeros are between here and here. Before the advent of technology, you might have had to do a little bit more just to narrow down your options. Instead of trying 64 different things, maybe you could narrow it down to, I don't know, 12. So if you got a guess and check, that definitely helps. It's also one of those random things that we kind of talked about ACT in here. You're going to hear me talk about it a lot, especially with juniors and seniors. It might just be that thing that pops up where they say, which of these is defined as a lower boundary of the polynomial. It might just be that 1 out of 10 random grab bag of everything from PreCalc and on that happens to be on your ACT when you take it. And I don't want to be the guy that doesn't show you. Okay, so now you know. If I plug in A, good old synthetic division, synthetic substitution, because it's a lower boundary, what happens? Okay, or zeros, because it specifically said non-negative or non-positive. So it could be like positive, 0, positive, negative, positive, negative, positive, 0, positive, right? It's just alternating non-positive, non-negative. So that might happen. Usually it's just positive, negative. And if I plug in B, what should happen if it's an upper boundary, meaning all the zeros are that way? All positives. Okay? So it's just one of those random things that I had to show you. Another one of the ways that I can cut down the number of things that I have to try, Descartes' rule of signs. We saw this back in Algebra 2. It says if I shove in a positive or negative x, I can count up the sign changes, tells me how many positive or negative real zeros there are. So, example. If I were to put in a positive x, well then it's just a positive x, a positive x, a positive x. None of this is going to change, right? Because a positive cubed is still positive, a positive squared is still positive, positive to the first is still positive. So if I plug in a positive x, I look at my signs and I get a negative, positive, negative, negative. And you count the number of times that the sign changed. And I say it changed once, it changed twice, and then it just kind of keeps going. If the sign changes twice, that means there's 2 possible positive real zeros. Or 0 possible. It's always going to go down in pairs. And we kind of talked about this before. I'm going to say 2 or 0 possible positive real zeros. Do you remember why it's 2 or 0? What goes in pairs? The imaginary ones, right? So here's an example. This is a cubic. Okay, if you want to sketch this off to the side, you can. Right now, how many positive real zeros does this have? Right, it crosses the x-axis on the positive side 2 times. Well, what happens if that was translated a little bit? What happens if it's right there? Now how many positive real zeros does it have? Still 2. Remember, it's acting like a parabola right there? Multiplicity of 2. Now how many? 1. Wait, 0. The last 36 hours have been something. It goes from 2 to 0. It doesn't skip and go 2, 1, 0. It's just 2 to 0. That means if I ever have a I, remember that I is square root of negative 1, but to get square root of negative 1, you had to have square rooted something, and you got plus or minus. So since imaginary roots always occur in pairs, that means it's going to hop down from 2 to 0. This goes for as big as, say I have 7 sign changes. Then how many possible positive real zeros were there? 7 or 5 or 3 or 1. Okay, say this was something a lot bigger. There, screw it. Right now, how many positive real zeros does it have? 1, 2, 3. But if I move up to here, then 1. If I move, well, I did that bad. I was trying to get the 5 or the 3 or the 1. I was just winging it. Okay. It's always going to occur in those pairs depending on where it translates to. Same thing happens with negative x's, except it tells me negative real zeros. If I plug in a negative x, a negative x here, a negative x there. Screw you. Okay. Y'all remember the trick? A negative to a positive power is positive. A negative to an odd power is negative, right? So if I shove a negative x in here, negative, 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 times a negative, it changes. So basically, if it's odd, it'll change the sign. If it's even, it won't, because a negative by a negative, positive, times a positive is still positive. It's to an odd power, so it will change the sign, because a negative x and then minus that is now positive. And the constant, well, constant is constant for a reason. It doesn't change. So again, I plug in that negative x and I count sign changes, and I see it only happen once. So I'd say there's one possible negative real zero. Now this is real zeros. It doesn't mean rational zeros. They could be butt ugly. They could be cube root of something. What the hell was that? It's like someone forgot breakfast and walked by and feed me, Seymour. Okay. Why didn't I go down? Why didn't I say 1 and then 0? Goes by pairs, right? And I can't say there's now -1 negative real zeros. Doesn't make sense. So the reason that we would do Descartes' theorem is, say I did my rational root theorem, and I know all my possible rational roots, and it's these 30 options. But then I do Descartes' theorem, and this happens. What numbers should I try first? There might be no positive numbers as zeros. It's possible, but there is one possible negative real zero. So I should start with my negative numbers because I know there has to be one. Because it never went 1 and then 0. Okay, even if it was bigger, say it was 5 or 3 or 1. Because it never hit or 0, I know there has to be at least one negative real zero. So I'm going to start with the negative numbers when I do my guess and check. Okay? Even better, because there's only one possible, when I find the negative, I'm done. Move on to the positives. Okay? So it was just a matter of putting in a positive or negative x and counting your sign changes. Okay, they're going to have different things happen to them, so I want you to try both. If you put in a positive x, it's just whatever it says right now. Count the sign changes. Plug in a negative x. Anytime there's an odd power, it's going to change the sign. Honestly, the only Spanish I know is Yo quiero Taco Bell. That's because a little dog told me. Go! Howdy.
Made it. By the skin of your
It was close, yeah. Got in like 10:05. Oh, once you hit the highway, everything's fine out there. Even in town here, the main drags are fine. If you can ignore the mountain in the median. Well, it's because they actually had their plows running yesterday, and then it melts off because it was all like 35, 40 degrees. So the roads are fine, except on the side streets where everything melted and froze. Then you got like icebergs everywhere. I'm outside of Bell, so we have no, it's just the homeowners association, and we finally had a couple of us just got sick of there not being a grader. Yes, sir. No. No, it took 5 of us who happened to have snow plows beating at our road for the last day and a half to finally get out. So I even that was the mechanic. I just had him weld up the supports on my plow. This stuff is so heavy that I cracked my plow's pivot. So yeah. Here we go. If I put in a positive x, it is what it is, right? So positive, positive, negative, negative. How many sign changes? Uno. So I'll say there is one possible positive real zero. I'll plug in a negative x. Are y'all okay if I just write the signs? Like it's just whether it changes or it doesn't? Okay. An odd amount of negatives will be negative. An even amount of negatives will stay positive. An odd amount of negatives will change the sign. So it's a negative, and then you minus the negative, positive. And then the constant is still negative. So I see 2 possible, or 2 sign changes. Okay, so 2 sign changes, I see this, and then I have to change it to account for the imaginary roots. It's not just 2, it's 2 or 0. Okay, so just remember to keep going down in pairs however far you can. Okay, a positive x, I see negative, positive, positive, negative, positive. How many sign changes?
3.
Okay, so I'm going to say there's 3 or 1 positive real zeros. It's important to say the word possible. Okay, this is how many possible real zeros there are. If I put in negative x, even does not change. Odd does change. Even does not change. Odd does change. And constant stays constant. So in that case, there's one possible negative real zero. So a nice part about that is you start with probably the negatives. Once you find your negative real zero, you know you're done with all the negatives. You get rid of the rest of them. Move over to the positives. Okay. Oh, your 12 by 24 tray of brownies is, yeah, y'all gonna get a slab like that. It's like a brick. Is still on my counter at home because I had to go beat at a snowdrift with my broken plow this morning. So I forgot. And every time you just ram up and whoa, my kid's in the back. Whee! So yeah, if I get a message at like 6:45 saying, "Hey, give me my brownies," I'll probably remember. Okay, solving. I put this slide out of order. We're going to come back to that. Right? Find each function. Oh, wait, no. That's right. They expect you already know this, so we need to do this right now. They just expect that you remember this. So the idea was, if I'm going to solve a polynomial, you have two options. Option one, you know how to factor it. Okay? Option number one is you know how to factor it. This is factorable.
Did we skip the last part of that page? Yeah.
Did we?
Yeah.
There's a page?
It just asks you to do more.
It says like list all possible rational. The next one.
It's just more examples. Yeah.
Oh no, this was just more like we got the whole rational root and Descartes Theorem and all that. Yeah, go ahead and cross off. Okay. So we kind of talked about factoring these by grouping the other day. Does anyone see how you can rearrange this so that you have quadratic form? You just got to rearrange it. There you go. If I say 2x to the fourth minus 87x squared plus 45, and then plus 9x cubed minus 49x. Okay, it's still the same polynomial, I just rearranged it. But now that I've rearranged it, I see these two, remember factoring by grouping, these two have an x in common, leaving a 9x squared minus 49. You're trying to mess with me. Okay. Over here, because 2 is prime, I bet most of us would be okay with jumping straight for this. Except they're going to be squareds, right? Because they're quadratic form. It looks like a quadratic. It quacks like a quadratic. Turns out it's platypus. Okay? So, what factors of 45 can I put here and here so that I end up with a negative 87 in the middle?
345. Is that possible? Because 45 times 2 is 90. But then only have 1.
So it's
multiples of 45. It's like at 15 to get negative 3 left.
You realize that you also have to take into account the 2.
Yeah, I know, but 15 times.
It's not working, is it?
No.
Okay. There is. Sorry. Okay. Okay. If that would have worked, you all remember how to do it, right? Because then you would see what the two parts of it have in common. And you'd take that out and then you'd factor what's left. And we know how to factor by grouping. This is something that we did not see very often, if at all, in Algebra 2. I know I tried to show my Algebra 2 classes this, and they hated it, and they just kind of tuned out. You have to split, just like that AC method, where you always split your B term in the middle. I have to split this. I have to somehow split that. Hmm.
3 is 29. And I was like, what? Sorry, I got confused. 3 and 29. Wait, no, I didn't. 3 and 29.
No, not into factors.
No, if you add.
What adds together to make it? Okay. So I'm winging it here. Don't write this yet because I'm tired. What if I said, what was it? Negative 90 and positive 3, but I don't remember if that's 6, 3, so it's going to be 90.
I think we just don't do that.
Okay. I do not have sufficient sleep or energy to do this because I can't think straight right now. So instead, I will do it later and I will send a screenshot when I can think. Right now I can't think because all that's happening is the little leprechaun on my shoulder screaming, "You're an idiot! You teach this? What's wrong with you?" So we're going to do the other way, which is the way that most kids like. Gaze into your crystal ball. Okay? Come over here and say, Claire. Oh man, this is a big honker. 2, 9, so 2x to the 4th plus 9x to the 3rd. Maddie, knock it off. Minus 87x squared minus 49x plus 45. Okay. This is the way that you were taught in Algebra 2, which is any polynomial can be fully solved by synthetic division, but I need to figure out what do I feel lucky about first. Not bad. I feel really good about a -9. I think that's a -1 and a 1/2. And a, what's that, 1, 2, 3, 4, 5? Okay. Now these ones, because of how close they are, I'm actually a little concerned that those might be radicals. So I'm going to feel lucky about -9 and 5 first. And say 2, 9, -87, -49, 45. And say I feel really lucky about -9. And say -9 by 2 is -18. Add them. -9 and -9 is +81, and add them. -9 and -6 is 54, and add them. -9 and +6 is, wait, 5. I said I can't do basic math right now. Quiet you. And multiply those and get -45.
When you try to shoot her with the Nerf guns, please miss me.
Okay. So -9 worked. I'm going to keep going. I'm going to try 5. 5 and 2 is 10. Add them is 1. 5 and 1 is 5. Add them is -1. 5 and -1 is -5 is skadoosh. Okay. What is that at the bottom? 2x squared plus x minus 1. A quadratic, because I've taken a quartic and I've reduced it by 2 degrees. Is 2x squared plus x minus 1 factorable? I'm asking you. AC method. Is there factors of -2 that add up to +1? Yes. See, here's the deal. If I have a polynomial, the goal is to get it down to a quadratic. Because at quadratic town, I know how to deal with quadratics. I've been doing it for 3 years. Now, in this case, it's factorable. I can now factor that. I could complete the square. I could square root. I could keep going because there's other numbers I feel lucky about. Okay, -1, say -2 is -1 is 1 is skadoosh. Try it again. And say, what was it, 1/2? We think it's 1/2. And remember, because I divided my 0 by 2, I also divide this by 2. The idea is you should be at 1 at the very end, the identity. Because now I know 1 times x minus 1/2 times x plus 1 times x minus 5 times x plus 9 will make this polynomial. And then you say, there's all my zeros. So x is -9, -1, 1/2, and 5. What I want you to get out of it, though, is once I got there, what if it wasn't factorable? What if it wasn't nice? What if there weren't any more real zeros that showed up on my calculator screen? That's why we have to know how to do this and not just rely on the calculator. Because if the calculator only shows me 2 real zeros and all I put on here was -9 and 5, uh-oh, I just missed half my answers. But once I get to a quadratic, I know how to work with quadratics. Quadratic formula or complete the square, whatever your jam is. Okay? So, can you take a thing and find all the zeros? Go. Okay, that's what I was trying to do before. I just can't think straight. Okay. I split my negative 17x. Negative 17x became negative 14x and negative 3x. Because now, those got negative 3 in common, these got an x in common. Factor the quadratic. Oh, look at that. They both have a x minus 7 in common. So if I take a x minus 7 out, it leaves, I'm going to have to throw this back in there, x squared plus 2x minus 3, which is x plus 3, x minus 1. Okay, so you can factor them, but you have to find the magic combination of how do I split something up. I know there's an algorithm for it. I was never taught it. And most of the time that I've run through these classes, it's insanely rare that a kid wants to do this at all. They would rather just dump it in their calculator and say, nah, I feel good about a 7. 1, negative 5, negative 17, positive 21. And say, you know what, I just feel really good about a 7. Yay. Y'all see the factorable quadratic now? X squared plus 2x minus 3. So I can just try 3. Negative. Linear factorization, breaking up polynomials to do partial words. Partial blank integrals. But I can't actually think of blank. Calculus. You will do it in calculus. You will need it in calculus. But you'll also review it then when you get to that. And then keep going and get the 1. So. That was kind of the heart and soul of Algebra 2. You remember how to do that? Like, look at the calculator. What do I feel lucky about? Do synthetic division until you get to whatever quadratic it is, or if you can take it all the way to the end zone. Okay, all real zeros, possible real zeros, we did that. All right, fundamental theorem of algebra. If I got a degree n, I got n zeros. Doesn't matter if they're rational or irrational, doesn't matter if they're real or imaginary, if they're pretty or they're ugly. If I have a degree 5 polynomial, I got 5 zeros. What they look like, who knows? But I've got 5 of them. Okay. Linear factorization theorem, which is where the factoring things from that last problem came in, is if I know the zeros, I can write the thing as a chain of linear factors. If I know that the zeros are 7 and negative 3 and 1, then I can say x minus 7, x plus 3, x minus 1. Okay? So if you know the factors, you can write, or if you know the zeros, you can write the factors. If you know the factors, you can write the zeros. And conjugate root theorem. We talked about it with our going down in pairs with our possible real zeros. Anytime I introduce a square root, I have to do plus or minus. If I have to do plus or minus, that means they always occur in pairs. So anytime there's a radical involved, it's got a friend. Okay? So if they tell me that 4 minus 2i is one of my zeros, it's an imaginary one, who else has to be a zero? 4 plus 2i. It's conjugate. Now technically, remember, if this is a 0, then that's the factor. It's always x minus the 0, however ugly the 0 is. If I hear that 1/2 plus Square root of 5 over 3 is a 0. What else is a 0? Yeah. And this is the linear factor that makes it. Okay, it's always x minus the 0, however ugly the 0 is. And we use that to work backwards. If I know the zeros, I can make the polynomial. Write a polynomial function, least degree, real coefficient, standard form, so I want to go descending order of exponents, that has these as zeros. Well, if I have -2 as a 0, it's always, I'm going to write them out ugly, even though you know how to do them. It's x minus the 0. It's x minus the 0. It's x minus the 0. Conjugate root theorem says if that's one of them, what else is? No, it's always x minus the 0. 3 plus I. And if I need to make the polynomial, I will now go distribution bonkers on it. Yes. Because. Okay, what I'm going to do is take them in pieces, right? If I told you to multiply 3 times 15 times 10 times 6, right, you wouldn't say 3 times 15 is this, times 10 is this, times 6 is this, because now that's 3 steps, as opposed to, I could say 45 times 60, right? And even then, I would probably do distribution in my head. I'd say 6 by 4, or 6 by 40 is going to be 240 with an extra 0. So 2400, and then 6 by 5 is 30, 2430. Okay, I'm going to do that in pieces. I'm going to do this in pieces. So we'll take x plus 2 times x minus 4, while simultaneously doing x minus 3 plus I, x minus 3 minus I. Y'all see I just distributed the negative? It's really common for kids to do the conjugates incorrectly with those and to say x minus 3 plus I, x plus 3 minus I. I'll see kids do that backwards. Okay? That's why I always use parentheses. Now, distribution bonkers. First one, x by x is x squared. X by -4 is -4x. 2 by x is plus 2x. 2 by -4 is -8. Womp. X squared minus 2x minus 8. You see how as I was distributing it, I put like terms under each other. It's a way to organize. This is why you learned multi-digit multiplication back in elementary school with place value. You always had to line them up. That's why you always put that 0 as a placeholder to move you over. Okay, so when I distribute these, watch how much comes out of this. X times all that stuff. X squared minus 3x minus ix. Cool? Okay. Now, I'm going to multiply by -3. -3 times the stuff. I'm just not drawing the arrows because it's going to look like a giant spaghetti monster. -3 times x is -3x. I'll put it here because they're like terms. I want to keep like terms lined up. -3 by -3 is +9. I'll put it over here because it's not a like term with ix. -3 by -I is a +3i. I'm going to put it over here because it's not a like term with anything else. There's a method to the madness. Because, now look at the I times x. I'll put it right here because it's a like term, right? Just like multi-digit multiplication. I'm lining up my place values. I times -3 is -3i. I times -I is -I squared. Yeah, we'll get there. So then what happens out of all of that is x squared, -3x and -3x is -6x. Ix's cancel, 3 i's cancel, and I squared is -1. So this is minus a -1, so it's really +1, right? 9 plus 1. Right? Because this is like 3 by 15 and 6 by 10. You still have to multiply those two together to get to the end of it. But this is, dude, real that's what you're gonna. So if I have x squared minus 2x minus 8 by x squared minus 6x plus 10, again, when I'm multiplying these, I can use that distribution to help me keep things arranged. If I take x squared times stuff, it's x to the 4th minus 6x to the 3rd plus 10x squared. Get down here. Then if I take a negative 2x times the stuff, I want to keep things lined up by like terms. So negative 2x by x squared is a negative 2x by 10 is negative 20x. You do it again. Say negative 8 times all this stuff. Negative 8x squared, I'm going to put it here so it's lined up. Negative 8 by negative 6x is plus 48x. Negative 8 by 10 is negative 80. And then at the end of the rainbow, see how all of your like terms are already lined up. This is why I do it like this, because my like terms are lined up for me. I don't have to. How many of you used to do this, or maybe you already did just this time, and all you did was distribute and you wrote it out in a big line? And it's just this big. Well, now you got a hunt in there for all of your like terms. Versus if I put a little bit of organization to it as I was multiplying, I don't have to hunt for them now. Now, my polynomial is x to the 4th minus 8x to the 3rd. 10 plus 12 minus 8 is 14x squared plus 28x minus 80. All from x is negative 2, 4, and 3 minus I.
I remember doing this last year.
Okay. Now what if I said I could get rid of all that and get straight there in one shot? Okay. Does anyone remember there being a quadratic cheater with those? Maybe. You should remember. Okay. Instead of all of that, I want you to look back here. You see how these terms canceled out and these terms canceled out? You see how we had 2 of these? Isn't 9 3 squared? And negative I squared was this squared? Okay. If I take the general form, I don't know if you got a corner to do this in or you just want to look at it. If I have a plus bi, an imaginary root, x minus that is one of my factors. X minus its conjugate is the other factor. Distribute the negative. X minus a minus bi. X minus a plus bi. Watch what happens when I distribute them. X times all the stuff. Cool? Just add an x to all of it. Negative a times all the stuff. Negative ax, positive a squared, I write it over here, it's not a like term, negative abi. You see how it's already starting to line up, kind of like the last one I did? Take a negative bi times the stuff. Negative bix, positive abi, negative b squared I squared. Look at what happens again. I get two of these terms. Those cancel, those cancel. I get the thing squared, and I get the thing squared. I squared is a negative 1. Getting x squared minus 2ax plus a squared plus b squared as my constant. So if I have this cheater formula here, this says if I have a complex zero, I can take a and b, never put the I, a and b. I can plug them in here and just get my answer. So go all the way back to what we just said. We had 3 minus I. What's a? 3. What's b? Negative 1. Not I. Remember, it's bi. So I would say x squared minus 2a x plus a squared plus b squared. X squared minus 6x, 9 plus 1 is 10. Every Algebra 2 teacher worth their salt shows kids this. Because I have never, this is year, was 2008, 13 for me, plus how, my lifetime tutoring. I have never, ever once seen this in an algebra textbook. Never. They don't put this in textbooks because they want you to do it this way because that's by the definition. But if I know that there's a cheater formula, oh boy, am I going to write that down. Now, what if this wasn't an I? What if this was like 1 plus square root of 2? And then 1 minus square root of 2. All this same stuff would happen. It's just this wouldn't be here, this wouldn't be here, this wouldn't be here, this wouldn't be here, this wouldn't be here. All the same stuff would happen because they're conjugates. So the only difference, if it's not an I, is at the end you won't have that sign change on you. So I would like you to write these two handy-dandy cheaters. If I ever have a plus bi, the quadratic that made it, x squared minus 2ax plus a squared plus b squared. I'm trying to think of the other one here. If I have a plus b, where b is a radical. Now, when I say b is a radical, I do mean that could be square root of 3, that could be 5 square root of 70. Okay? Anything is a radical. Then it's going to be almost the same thing. It's just we're not going to have that I squared at the end changing this sign. Write those cheaters down because they save you about a third of your work. In our school, no. In a college environment, y'all, some of those professors just got a stick lodged so far that I can't guarantee anything. Like the one class, y'all know when you get to college, in your major field, you have to get a C or better in every class to move on to the next class. Because if you don't have a C or better in the content that you're in school for, you should probably know that better. The one class I had to retake because I ended up with a like 69.2 was because of one of those crotchety old math professors. I was the on-call residential director for the group home I worked at, and there was an incident at night. I just stayed at the group home to do my assignment after filling out the incident reports afterwards. I submitted it at 12:02. Deadline was midnight. I'm like, dude, this is my primary. He's damn near like my kid, and he went to jail tonight. Can you give me a 2-minute break? Need to choose your priorities better. He was that guy. Like, it was bad. All right. So I'm going to do this again. Yeah. I would get called out of class to answer the phone. Like, you step out of the lecture hall and in the hallway and what? No. Put him on the phone. No, go get him. Unlock your door now. I don't care what Mike did. If I have to leave class, the next time we have a primary outing, I'm bringing you to the gym. Kid was like 300 pounds. Do it! And behind me, the entire class has gone silent. Like, I had to do that kind of stuff. And the dude got all crabby just because, I was taking care of my boys instead of... If I see this, they just wrote the conjugate for me. Okay, don't do it twice. Don't say, well, if this is 1, then this is 1. And if that's 1, then this is 1. Okay, don't do it twice. They just wrote the conjugate for you. All right? So, you notice how it's not like 5 plus that? That means it's not in A plus BI form. I can get away with just saying X minus that. Okay? Because it doesn't have the real and imaginary parts. That's why I wanted to show you this one. Because when I distribute, I'll have x squared minus 2 square root of 3x, but then plus minus 2 square root of 3x minus. You see how they're going to cancel anyway? Okay, so that's why I didn't have to do the full cheater form. And then, y'all remember what happens when you square something like this? Square inside, square outside. So 4 times 3, 12. And then those will cancel out. So it's just x squared minus 12. I can do that, or if I just see this, isn't it also 0 plus 2 squared root of 3 as a rational, irrational part? Right? Like the rational part, instead of saying 5, we just have a 0. I can still use the cheater on this, and it'll still get me here. I would say x squared minus 2ax plus a squared minus b squared. Remember, I'm using minus because there's no I here. And I would plug in a is 0, b is 2 square root of 3. Do you see how you still end up here? So that cheater works whether you have an A and a B or not. So I just wanted to show you that. Okay, I got that one. This guy. It's got an I in it. So I can go bonkers. I can say x minus 1 plus I, x minus 1 minus I, because that's what some crotchety old math professor is going to want me to do. Or x squared minus 2ax plus a squared plus b squared. I can run this instead and say a is 1, b is also 1. This is the mechanics that allows you to do the real world stuff later. You're going to see this a lot in PreCalc, where it's a pre-calculus class. It is literally the foundation to go do the cool thing. Yeah. So I get x squared minus 2x, and 1 plus 1 is 2. But look at that quadratic. Are there factors of positive 2 that add up to negative 2? Okay, it wasn't a factorable quadratic, right? You would have had to go to quadratic formula to get the zeros. So that's how I know ugly zeros made ugly quadratic. Okay? And then distribute this. X squared times all the stuff. If you want me to spaghetti monster, I will on this one because it's 2 terms. So we get x to the 4th minus 2x, wait, 3rd. I can math, I swear. 2 plus 1, I can do that. And x squared times 2 is 2x squared. And then negative 12 times all the stuff is negative 2x squared, 12x squared, plus 24x minus 24. And then combine like terms. Okay. So sometimes you got to use a cheater. Sometimes you can get away with something simpler. All depends on your preference. Everyone got to there? Okay. So we don't have a lot of time. I'd like you to do that one because it's nice and easy. What does that mean when they say multiplicity 2? So you're going to have to say x minus 1 and another x minus 1. So let's just see if you can do that. And I'll just straight up tell you right now, your assignment online is not correct. I did not touch plan book. In fact, my internet's been out since Tuesday afternoon at home. Yeah. Well, plus the internet's just trash. So. Oh yeah, Leading Deadwood just got pounded. Yeah, you. Good luck with that.
So then when they start making snow up at Terry Creek, that also comes to my house. So I just get.
Yeah, when do you think Terry's gonna open?
Normally open. But I don't know.
They might open early this year if this sticks around.
But also it's supposed to be like 70.
Yeah.
So I don't know. We're gonna get second fall now. Second winter will fit.
Okay, that's the thing. Like, I want to go, but I don't want to be that.
Yeah, we get full.
All right, come on, dial it back in. Do you have that as your linear factors? If I'm going to multiply these, what makes sense to multiply first? the easy ones. Okay, I'm going to put together the stuff with i's because that's x squared plus 16. Right? Because you'll have minus 4ix plus 4ix cancel. And then negative 4 times 4 times I squared will change your sign. The more of these you do, the more you just get used to, oh yeah, it's that thing. I'm actually going to do those too because it's a binomial squared, right? Square the first term, square the last term, multiply and double. So I can use my mental math tricks on those. But then I've still got this goober back here. Okay. So what I'm going to do,
We can't do that.
I'm going to send that over there. When I was extra tired with Goblin number 2, when he was a baby, there were times where I'd be working with a student and I would actually tap their paper to try move what we wrote over because I didn't realize I can't do that.
They should make that.
X to the third, 3x squared plus 16x. Y'all cool with that? Right? X squared times the stuff, 16 times the stuff. Finish it off. X squared times all of that is x to the 5th plus 3x to the 4th plus 16x to the 3rd plus 48x squared. Negative 2x times all that stuff is negative 2x to the 4th minus 6x 3rd minus 32x squared minus 96x. Keep going. I'm just going to finish it off so it's on the video. Third, what's that? It's 16, 19x squared, 80x plus. Ugh. Okay.